element families. Hopefully we are all happy by now with the concept that all the rows in the periodic table are the periods. Okay, so rows are called periods, and there's 7 of them. Okay, groups are the columns. Okay, so the columns are what we call the groups, and there are 18 of them. There are a few different ways of ordering the numbering of the groups. So some textbooks will say like 1, 2, no man's land, 3, 4, 5, and then they have Roman numerals and stuff. The more modern way of naming them is just go 1 through 18, because that's how numbers work. So we're going to stick with that in this class, okay? Because that seems much more sensible. Okay, so that's the group numbers I'll be using. So some groups, especially ones that have been known about for a long time, have names as well as numbers. So it's very common to refer to these groups by their name, and you got to know some of them. So group 1, which is this one right here, is the alkali metals. So group 1 is the alkali metals. So from now on, because you've been told that, you know, if someone says alkali metals, they're talking about group 1. Let's, I guess, pick a different color. Group 2 over here. I guess I could have picked the ones that match the this, but yellow and orange is kind of hard to see, right? So group 2 is called the alkaline earth metals. So a lot of this is to do with their reactivity, right? So if you dissolve group 1 and group 2 metals in water, this is where most of our hydroxides come from, as long as they're soluble, right? So alkali metals are much more reactive with water than alkaline earth metals. Anywho, groups 3 through 12, that is the transition metals. So if you at least know that kind of zone, that is great that you know that that is the transition metal zone. Transition metals. Oh, that's like the most fun bit right there. So in between groups 3 through 10-ish. Okay, so come off. Ah! Where did you go? Sorry. Transition metals. There are some exceptions, but they're around about this area right here. And then group 13 and 14 don't get names really. Sometimes they're called the boron group, sometimes they're called the carbon group, depending on which one you have. So we don't have to worry about giving those a fancy name. That's nice, isn't it? Then when we get to group 15, group 15 is what's called the pnictogens. It's one of those funny P's that you don't say, like pterodactyl, right? So group 15 is the pnictogens. Comes from the Greek, I believe, for to choke, because nitrogen gas is not toxic or anything, but if it replaces oxygen, right, in the air, like you if you don't want to be stuck in an elevator with a exploding canister of nitrogen, because there'd be no oxygen to breathe, right? So that is the pnictogens. Another group, group 16. Let's pick a different color. Here we go. Group 16 is the chalcogens. Did you know that's how we say it? Chalcogens. That's how I say it, so it must be right. Coming from chalkos, which is again, I believe, ancient Greek for ore. Ore forming, the chalcogens, because look at what's the top here, oxygen and sulfur, and 9 times out of 10, maybe even 99 times out of 100, if you dig some metal ore out the ground, the metal is bonded to either oxygen or sulfur. That's very common in minerals, etc. The reasons why, you have to get to like later on in organic chemistry to cover that. Okay, so then next up is group 17, the halogens. There you go. Let's go brown. Why not? Halogen again is from Greek, I think, which is salt forming. So it's group 17, the halogens, because they form halides, which is halogen salts. Okay, those are also super reactive. So when we start talking about ionic compounds and stuff, you'll find quite a lot of halogen salts and stuff. And finally, guess I'll use black. The noble gases. The noble gases don't tend to react with anything, okay? We need to understand about electronic structure, where electrons go to really understand it, but they don't really react with anything, so that's why they are too noble to react and form compounds. It is above them. This bit down the bottom is altogether referred to as the F block. This bit down here The F block actually fits in, as you can see, right here. So lanthanum comes in between barium and hafnium and all its buddies after it. So lanthanum through lutetium slot in here. As you can imagine, that would cause a bit of a formatting issue for periodic tables. And then actinium comes between radium and rutherfordium in here. So actinium and all its buddies up to lawrencium go in there. Okay, so the names of those two rows in the F block are just derived from the element at the start. So the top row is the lanthanides or the lanthanoids, but there's grammatical semantics there we don't need to get into. So lanthanides means all of them except lanthanum, because it means like lanthanum, and lanthanoids I believe means all of them including lanthanum, but I could have got that the wrong way around, so I'm not going to test you on that, that's for sure. So these are the lanthanides or the lanthanoids, and similarly these are the actinides. And actinium is one of my least favorite words to say because, you know, well, you heard me just try and do it. Okay, so we are going to be asked several different kind of questions in this, just making sure we know the common names for groups if they have them, and just can find our way around the periodic table. So we're asked for the name of the element family that bismuth comes from. So bismuth in here is in group 15. So bismuth would be a pnictogen. And sodium over here, remember sodium is Na, is going to be an alkali metal. Alkali metal. Okay, so let's just pull up another one and make sure we've sort of seen all the things to see. So beryllium and sodium, we've just had that one, so I'll just answer beryllium. Find beryllium in the periodic table. Beryllium's right here. It's at the top of the alkaline earth metal. So beryllium is an alkaline earth metal. Sodium is an alkali metal. All right, one more, because we've got a bit of a repeat there. Nitrogen and lithium, lovely stuff. So nitrogen is at the top of the pnictogens. Pnictogens and lithium. Lithium is an alkali metal. So just learn those group names. Something went wrong with my thingy. So be able to translate between somebody saying, hey, this element, what group name is it in? Or this group name, which elements are in it? Okay. All right. So make sure, I'm sure some of them you already know, but just make sure if there's ones that are unfamiliar to you that you learn them.